Rahim. Welcome to part 4 of lesson 2, creating your first application of Levy 1, Levy Core 1 training. Okay, now we will discuss tools for programming, cleaning, and organizing your VI. In this part, you will learn recognize tools for making clean, readable front panels and block diagrams and for documenting VIs. You will learn programming tools, wiring tips, and how to make your code readable. Alright, so the first thing that we are going to learn is how to use programming tools in LabVIEW. And related to this programming tools in LabVIEW, there is also one exercise, that is exercise 2.1, in which you will learn to select a tool from the tools palette, and we will discuss what is the function of every tool of the programming tools palette. So I would demonstrate the programming tools, and in parallel I will also perform this exercise 2 when selecting a tool together. Alright, so let's discuss programming tools. Alright, programming tools. Why do we use programming tools? You can create, modify, and debug VIs using the tools provided by LabVIEW. LabVIEW chooses which tools to select based on the current location of the mouse. If you need more control, use the tools palette to select a specific tool. How? Let's see. Go to View and go to Tools palette. This is the Tools palette. Now in this tools palette there are different programming tools which have different functionalities. Mostly we use this automatic tool selection, which automatically selects the tool depending upon the current location of the mouse. But if you are interested, if you need more control, you can use the tools palette to select any specific tool. There are different tools, as you can see, and we'll discuss and demonstrate every tool of this tools palette. Alright, so let us perform our exercise 2.1, selecting a tool. And for this you should go to exercise core 1, and then you should go to Levy core 1 using temperature. Go to using temperature, you open this Levy project. Always open Levy project to remember this point, please. And then open this VI, use temperature.vi. Now this is the front panel and this is the tools palette which is open. Alright. Now here what we are going to do, it shows an example of the front panel as it appears. Now you will modify this front panel from different steps. You will try to do different things, like you will try to increase the size of the waveform chart, rename the numeric control, change the value of the numeric control, and move the knob. So you will perform these activities on this front panel using the different programming tools of this tools palette. First of all, let us discuss about positioning tool. Alright, so this is basically position tool. What is the purpose of this positioning tool? We use this positioning tool to select or resize the object. So if you want to select an object or you want to resize objects, you can use this positioning tool. So select this positioning tool. Right now I've selected this positioning tool. This positioning tool is selected. Now you should move the cursor to the right edge of the chart waveform chart until you see the resizing nodes appear on the chart. Like here. You see this node appears. Now move the cursor and now drag it. Resize the waveform chart. Now you see I am resizing it. Similarly, I can also resize this one as per my need. Okay. Drag the repositioning node until the waveform chart is the size you want. So you can also vary its size. Alright. This is how you use the positioning tool. I hope this is clear. So positioning tool is used to change the position of the object, resize the object, or select the objects. Alright. Now now I will discuss how to use labeling tool. This is called labeling tool. Using labeling tool, you can enter the text in a control to edit a text or to create free labels. You use this labeling tool. Click this tool and after clicking this labeling tool, now double click the chart, this chart, and then rename it and name it temperature chart. Now I click here using the labeling tool, I change its name to temperature chart. Alright, so this is the purpose of the labeling tool. So labeling tool helps us to enter text in a control or to edit text or to create free labels. Say suppose you want to create free labels, you can create this free label like this front panel, this front panel shows chart, numeric control and delay multiplier no. So this is called free label, and free label you can also create free label using this labeling tool. All right. Okay. After that, change the name of this numeric to number of measurements using the labeling tool. Again, we have this labeling tool is still available. Now change it to number of measurements. Rename this numeric control to number of measurements. So you see, using this labeling tool, we can enter text in a control. All right. Now use the operating tool. This is operating tool. Use this operating tool. Why do we use this operating tool? This operating tool is used to change the values of a control. Say suppose here its current value is 0. Make it 100. How can we change its value? By using this particularly operating tool. So this is the purpose of using the operating tool. Say suppose vary this number from 100 to 500. So you can do this work by using this operating tool. Or now let us change the setting of this delay multiplier node using the operating tool. Alright. Now for now it is set to 2. Vary it and set to 1. So I click here, I change 2 to 1. Now it is varied. So why do we use the operating tool? Use the operating tool to change the values of a control. Like here we change the value of a numeric control and delay multiplier node. Alright. Okay. So up to now we have discussed operating tool, positioning tool, and we have also discussed labeling tool. Click the automatic tool selection button to again turn on automatic selection tool. This is automatic selection tool. Mostly we turn on automatic tool selection because automatic tool selection can perform all these operations if you have selected this automatic tool selection. Let us say this automatic tool selection is selected. I can vary the name of the chart. Like I can click here and I can vary its chart. Let's change this name to temperature chart. VI. I can vary it. Alright. You want to change the value? Change the value to 600. Or say suppose you want to vary this knob to 5. Let's make it again 1. So you can do these works, all these works together by just choosing the automatic tool selection. Alright. So when automatic tool selection is selected, LabVIEW automatically chooses a tool based on the location of your cursor. You can turn off automatic tool selection by deselecting the atom or by selecting another atom in the palette. Alright. Okay. Now let's move to the block diagram. Press Ctrl T and go to its block diagram. Now this is its block diagram. Now use the positioning tool. This is the positioning tool. Turn it on and move the cursor to number of measurement terminals. Move the cursor over the terminal until the cursor changes to an arrow like this, and then drag the terminal to this location right here. This is how you can drag. You can drag it, move it anywhere. See, using this positioning tool. Alright. Then you should connect it to number of measurement terminals to count terminal of the for loop. This is a for loop. Connect it. How can you connect it? Now you see, you cannot wire it with the positioning tool. Positioning tool is specifically for changing the position of the object. Alright. Or resizing the object. But if you want to wire for this, you should use this connect wire tool palette. So what is the purpose of connect wire or wiring tool? Use the wiring tool to wire objects together on the block diagram. When you want to wire the objects, you should use this connect wire tools. Click it, then you can wire. See, I am wiring it. So this is the purpose of this wiring tool. Alright. Okay. So now we discussed about different tools of this tools palette. Also, say suppose I am clicking this automatic tool selection. Say suppose now if you have if your object is like this and you want to make this wire clean, you can click this clean up selection to clean the wire. Alright. Okay. Now let's move ahead. Say suppose now we are interested to change the boolean text of the stop button. Alright. So how can we change the boolean text of the stop button? Okay. Right click the stop button terminal and go to the properties. In properties, you see this is control label. Okay. This control label text identifies the terminal of the boolean control for programming purpose. The text does not appear on the front panel unless you select visible. Now visible is not selected. Therefore, if you see, the text will not be visible here in the front panel. It is not visible in the front panel as you can see it. Alright. So again go to properties, select visible. You will see this text will be visible if you click visible over here. Alright. The other option is boolean text. This text appears only on the front panel and by default appears in the center of the boolean control. You see on boolean control this stop is written. If you change it, you can change it, like make it end. write end here. Now if you click OK, this end will be appearing over here. So using boolean text, you can change the text of this stop button. All right. Now click the run button to run this VI. Let's run this VI. Right now number of measurements are 600. All right. What happens? You can see that this VI is executed how many iterations? 600 iterations. Depending upon this wait until next millisecond multiple. Now delay multiplier 0, therefore delay is, delay is very low. If I increase this and if I run it, now you see the VI is running slow because overall this wait until next millisecond multiple has large value now because 500 is multiplied by 1. So after every iteration it waits for almost 500 millisecond. So every iteration is performed after 500 millisecond and total 600 iterations are performed. If I make this delay multiply 0, it will be quickly performed because there will be no delay when for executing the iterations. All right. Okay. So the time required to execute this VI is equivalent to number of measurement times delay multiplier. When the VI is finished executing, the temperature chart displays the data. All right. So in our this exercise, we have covered how to use different programming tools of the tools palette. All right. So let's move ahead. One thing more, you can also use shortcut for this is type the shift and right click your mouse button. You will get this tools palette available. All right. So there is one other option. This is called a coloring button. So using the coloring button, you can vary the colors of the objects. All right. Use this coloring button to vary the color of delay multiplier knob. Okay. Make it red, and this one make it green. So you see, you can uh, give colors to your objects by using this coloring tool palette. All right. Okay. So far now you have discussed different tools palette of the programming tools. Okay. Now let's move ahead. Okay, demonstration wiring tips. For this, I open this 8VI. I press Ctrl T. Now, say suppose you have broken wires in your VI. Then how can you remove those broken wires and how can you clean up wires? Simply, you have to press Ctrl B for this purpose. If I press Ctrl B, then all the broken wires will be removed. Press Ctrl plus B. See, all the broken wires are removed. So this is a shortcut key, Ctrl plus B, to remove the broken wires. Say suppose I want to clean up this wire. This wire is not properly connected and I want to clean up this wire. How can I do it? Okay, please make sure that mostly we use this automatic tool selection. Therefore, this automatic tool selection should be activated. Mostly we use this automatic tool selection in our LabVIEW. Alright, now double click it and make this wire clean up selection. So this wire will be cleaned up. If you want to clean up this wire, right click it, this wire will be cleaned up. And if you want to clean up all the block diagram, you should select all the block diagram and clean up. Now you see, it's now block diagram is cleaned, and you see a better block diagram right now using this clean up diagram. All right, okay, let's move ahead. We have performed this exercise. You should also practice what you watched in this video and this exercise. Try to practice same thing using your LabVIEW in computer. Okay. Okay, let's discuss now demonstration making code readable. How to make your code readable. All right. Okay. Block diagram components can describe the function or operations of algorithms and can explain the purpose of data that passes through the wires. Alright, there are two types of labels in LabVIEW. One is called owned label and other is called free labels. You see, these are the owned labels. This name is the owned label. This is the owned label. This is the owned label. What is the definition of owned labels? They explain data contents of wires and objects, and they move with the object. If you move the object, owned label moves with the object. You see, they move with the object. All right. They have transparent they have transparent backgrounds, and they are created by selecting visible items label from the shortcut menu. See, if I go here visible item, if I remove this label, this will disappear. If I make it visible, I can make it visible. All right. And what is free label? Free labels are basically used to describe algorithms. Like say suppose double click it. Now what is the purpose of this algorithm? This algorithm adds two numbers. So you can create a free label and write here that this algorithm or this VI adds two numbers. This is now called free label. And you see, free labels have pale yellow background, and they are created by double clicking in any open space. Alright. Okay. So what are the free labels? They are used to describe algorithms, and you should use free labels and you should use owned labels properly, so that if someone else opens your VI, that should be readable. Your VI should be readable to others as well, and you should also understand your VI after you open it. After a couple of months, you should be able what you did in your program. So owned labels and free labels beautify your coding. A good LabVIEW programmer use properly owned labels and use properly free labels. Say suppose I can change its labeling as well. Say suppose this is number A and this is number B. Say suppose this is output and I name it Y. So you can change the names of own label as per your application and as per your need. All right. Okay. So what are the guidelines for labeling? Use free labels to document algorithms and add reference information. Label structures to specify the main functionality. Label long wires to identify their use, contents. Label constants to specify the nature of constant. To avoid clutter, document the context cell window or sub-VIs or functions instead of labels. Alright, now I want to highlight another important feature of LabVIEW, that is default values. Say suppose I give it value of 50 and I make it 30. Alright, why do we set default value? Setting a default value on a controller indicator can aid in future development and troubleshooting by giving the program an idea of the expected data for the object. When you want to open a NVI, if you go to data operation and make this value default value, like say suppose I go to data operation, I make current value is default value, I make this current value to default value. So now this will help me to remember that what is the default value that I should use. That default value will help me for my future development and troubleshooting by giving the program an idea of the expected data for the object. Alright, if suppose when I run it now, I get 80. Let's change this number 980. 80 plus 30 will be 110. And say suppose now I want to again make this value to default value, but I don't remember what was the default value. I can right click and go to data operation and reinitialize to default value. Then that same default value will be reinitialized. See, 50 was the default value that is reinitialized right now. So thank you very much. This was the part 4 of lesson 2. We will continue with part 5 in our next video. Thank you very much.